This conference will now.
At the same time, you are progressing to keep your progress. Hope the situation will recover back soon. So I will just give a quick eye opener about what is PCBs and what is this industry is about. Let me share my screen first. Okay, do the screen is visible?
His mic is visible.
Okay, okay, thank you, ma'am.
Okay.
Okay, generally, guys, the PCB industry for a triple E graduate, it is tough to know because I came from R.M.D. I don't know what is PCBs and what is this industry is about. I learned by getting into this industry, but all the basics which I learned in my 4 years of engineering helped me to become successful in this industry. So I will give a quick overview of what is this industry is about and what are the challenges it is facing and what are the opportunities it is available now and in the future. So at first, I will give you what is generally is about PCBs. Printed circuit boards, which are nothing but boards that provide mechanical support and electrical connection to electrical and electronic component. So when we look on into the evolution of the PCBs, first it all started with wire wrap, which is nothing but in the late electronics development and the circuitry development started around 1950s. So at first, in order to make the functionality of the circuit, they used a technique called wire wrap, where a cardboard or a piece of wood or any substrate is taken. At that time, only all the electronic components are manufactured using through-hole tech. So in the board or in the cardboard, holes are drilled, components are placed, and interconnection between the components are made through with the help of wires. So the major drawback is it is quite complex to debug and it can't be incorporated in your day-to-day life electronics and your gadgets. So next came the evolution of point-to-point connection, which is nothing but a breadboard which we are using in our laboratories now. I hope all of you are familiar in using a breadboard without a wire. But think of guys using a breadboard to make the circuitry, because electronic circuitry is the heart of the any electronic. Software comes next, but at first it is the hardware that matters. So if I make an electronic circuitry using a breadboard, can I accommodate in your mobile or in your gadgets, electronic gadgets or consumer electronics which you are using in your day-to-day life? It is hard, right? Because if any one connection has been lost, it is the entire circuitry will fail. So with that as a drawback came the next stage, which is known as printed circuit boards. These printed circuit boards are nothing but boards which are staked like conductor, dielectric, conductor alternatively. So the conductor dielectrics are staked alternatively. I hope you are familiar with the dielectrics, dielectric strength, loss tangent, which you all will be studying in transmission and distribution, because that is the basic. Trust me, guys, for a triple graduates to shine in the PCB industry, it is really great because all the concepts which we study and which we do in electrical applies the same to the PCBs. This dielectric constant, dielectric breakdown, lots and lots of technical terminologies we are dealing in our day-to-day printed circuit board designing. And this one, I'll explain with the image what is this PCB composite of. This one is this green trace is a conductor which provides connection from one component to another component. This one is dielectric, and there then comes conductors, then dielectric, conductors, dielectric. So it is a four-layer board, but the thickness is very small. So these boards make the functionality of the circuit, but while designing this board, we have a lot of challenges. Let me elaborate what are the challenges and how we are sorting it out. To, to make the printed circuit boards small and feasible, there plays a major part in packaging tech, which you are well aware. So in the early stage, through-hole tech is the main player in the market, but now through the miniaturization and lot of advancement in the lithography tech, there comes the evolution of SMT, which is nothing but surface mount tech, which this packaging technique helped us to reduce the size as well as to accommodate hundreds and thousands of components in the small area. So with this as base, I'll get into how these PCBs are designed and how it is manufactured. So the design process typically involves schematic capture. Schematic capture is nothing but first based on the application requirement or the product, the circuit will be designed where an engineer will check whether the circuit is functioning. Based on the designed circuit, this based on the design circuit, it is nothing but like a MATLAB simulation we will do here. So again, this single part is a vast industry. So if you are strong in your electronics like RLC and ICs, so and so stuffs, you can get into this industry, which is nothing but application requirement will be given, and you will be designing the circuit entirely from top to bottom. After designing the circuit, there comes this data will be transmitted to a PCB designer, where he will be responsible for making the making trans he'll be responsible for transferring the symbols to the real real prototype. So PCB designer's job is to lay the component on the board and ensure each component is connected and check whether the circuit functions as desired. So again, the the PCB designer has major impact because he he as a single man has to handle a lot of stuffs. After PCB designing, it is not like I design a board directly it goes to production. There's another vast industry which is analysis part. Actually, in this analysis, lots and lots of again concepts comes. The major analysis is whether the designed board is manufacturable, because I will design a board. If it goes to a manufacturer, it can't be manufactured within machineries. So there comes again a separate entity. We will call us EMS, Electronic Manufacturing Service Sector, where the boards are manufactured, and then the design and manufacturing is done in the same company. Only few company does nowadays. Design is done by the product owner. Manufacturing is done by some other company. For example, Flextronics, that sort of companies are EMS related one. So the first thing the designer needs to ensure is that whether the designed board is manufacturable, and then comes the this is nothing but physical design rule check. Then comes logical design rule check, where they will ensure whether the desired circuitry function is stable. Here they will also check for electromagnetics compatibility based on the four Maxwell equations, which you are familiar. So after the electromagnetics, there will be analysis on power distribution, how the power is getting distributed in my board, how the power is traveling in the conductor. The same the same concept which you will study in transmission, like how power is generated, how power is distributed. The same logic applies here. We are using two-port network to determine how this power is getting transmitted, how much of power is getting reflected, and how much of loss is occurring. So two-port network is the basic thing we are using for power distribution analysis. And then comes the stability of the circuit, where we'll be using Bode plot and polar plot and check the stability. If the circuit function is unstable, we will adjust gain margin. So lot of stuffs involves in logical design rule check. After, if any one of the things in this analysis stage fails, design need to be corrected. So it is an iterative process where it will keep on iterating. Once this analysis is fine, then goes this directly goes to production. So this this entire schematic capture, PCB design and analysis are carried by a tool, like we will call it as electronic design automation environment, which are the EDA providers. So with the help of the tools, we will carry out this process. So I think, let me explain with this part in a more practical way. This is a just an example of a boost converter. This one is the schematic capture stage, where we will capture the circuit and first run the simulation and verify whether my desired load is functioning as per the requirement. So this one or input filters, this output filters, and this is my circuitry. For just, it is just for example, so I have not designed the circuit, it's a IC completely. Just I have made the gate pulse to MOSFET. So this is the schematic capture stage. This schematic capture will be delivered to the PCB designer. So as a PCB designer, at first what he does is that for each and every component there is a mechanical dimension. For example, this is an IC, and guys, uh, if you are strong in your basics only, you can get the required information from the data sheet, or else it is going to be quite tough. So every component, there will be a data sheet. In that, this one is the typical IC symbol which is going to function, and you need to get out, all this, you need to study all this informations and get what is the value required. I will tell you why these values are important. And this one is the IC's internal circuitry. Here you need to concentrate more and more of things during designing stage. This all are digital electronics plus LIC combined. So at the output stage, these are the pins output. You need to ensure whether there is any high impedance MOSFET or open drain MOSFET, or this one is op amp. So what is this gain? So that sort of things you need to ensure, because there will be a lot of problem after designing. So here, this is the IC's mechanical dimension data, and again comes here. This can be interpreted only if you are familiar with your engineering graphics, top view, bottom view, so and so stuffs. So with this data, you need to extract what is the IC's mechanical outline. First, you need to extract these things, and then with the help of this is the mechanical dimensions of MOSFET, and this one is IC. So the primary job of a PCB designer is to create this outline, mechanical outline of any components. The first and foremost thing which you will do if you enter into any PCB industry is to create this component's mechanical outline. Here, everything will be mapped. This symbol will be mapped to a equivalent footprint, which is nothing but mechanical dimension data. See, C1 is the capacitor, it will be mapped to corresponding mechanical data. So this is schematic capture. So once I'll export it to the PCB designer, the equivalent mechanical dimension of the components will appear here. So how the data transfer is done between the schematic capture and the PCB layout editor is through netlist. Netlist Netlist is the common mode of data transfer in the electronics industry. So you will go generate netlist, and after generating the netlist file, you will be importing it here. This one is the netlist file which I have generated. After generating, I will import it to here, so that each component's mechanical data will be present here. And after placing the components, there are a lot of tough situation and challenges which a PCB designer need to handle, because for example, your mobile phone outer dimension is fixed, right? Because for a 5-inch phone, its X and Y is fixed. So the PCB size is also fixed. So there will be a mechanical outline which will be provided. So based on the mechanical outline provided, we need to accumulate all the components within the stipulated area. And these are my connectors. These are my connectors. This connectors location will be fixed because your USB charging will be location is fixed, either bottom or top. This location will be fixed. This and this location will be fixed. Based on that, you need to place other components. So I'll give a quick overview. What are the things we will consider during placing the components and making interconnections between them? This, I told you, these are the input filters, right? So these filters have to be close to the input connectors, because this one either comes from battery or some form of supply. There can be noise, so this noise has to be limited in the starting stage itself. If it travels, again there comes propagation constant, attenuation, lots and lots of, again, these terminologies will come into play. So there will be a propagation delay. So all these things will be present here. So we will encounter a problem, and my input signal will get completely distorted. So this input filters has to be close to the input connector. At the same time, this output output filters this output filters should be present near the output connector. I have not placed here. I'm telling, just it is just for example. So after placing all the components, since time is short, I will just take this as an example. After placing all these components, we will just connect this. After placing, we will just connect this. So the process goes on like this. But this is my conductor, which is going to connect between the components. The conductor's width will be fixed based on the amount of current it is carrying. There comes current density, so on, lots and lots of parameter where we will consider. And there is a standardization. So based on the standardization, we will calculate the trace width. So if capacitor and inductor are placed too far, is there is any problem? So at most at the design stage itself, we will try to sort out all the problems which will be occurring. But since nowadays the complexity of the circuit increases, we are facing a hectic time. So this trace width has lot of problem. If I take like this, the angle from the pad should be 45 degree. If it is 90 degrees, there comes total internal reflection concept, where my incident wave will be reflected and what is the reflection ratio. So 90 degree is not preferred because of the ringing problem, which is nothing but reflection coefficient, that sort of things. And the main thing which you need to consider is this MOSFET. This MOSFET, it is a switching element. So since it is switching, there is a lots and lots of possibility of transients. So if the gate pulse we have applied, we will check for transients, whether there is any transient. So we will try to maintain, since IC is going to provide the gate pulse for the MOSFET, we will try to maintain the distance between the IC and the MOSFET as short as possible, in order to ensure if my gate pulse travels in a long distance, due to traveling at a long distance, there occurs capacitive coupling, inductor coupling, and crosstalk, lot and lots of crosstalk problems. So my gate pulse will get completely distorted, which will trigger the MOSFET in the wrong time intervals. So this is the live example of what I explained here. This is the PCB design area. So this is the sort of thing we will be doing, and we will also be ensuring the design will not fail during the analysis part. So after this designing stage, there comes the manufacturing. So how the board is manufactured, we will just take a dielectric. If the area is 1x1, we will take a dielectric for 1x1 and stack the copper for 1x1, and we will do a photo etching process, where this is the copper area. There is no copper here. So using photo etching, we will remove the unwanted coppers. Only the coppers which are connected from one component to other component will be made available. So after this, it will be transferred to the assembly line, where the components, SMT components, XMT or through hole components are assembled in the board. So these are the stages in the assembly line, where paste printing is the basic process, which is nothing but, like, I hope you you all have done you all have experience with soldering, where you will use lead and a flux. So the lead and a flux, you will use flux for oxidation, to remove oxides which are present in the lead or any substrate. So you will use lead and a flux, and you will solder components. So imagine that process is automated. So here in the paste printing stage, they will consider this as the components pad. So here the paste will be paste by the SMT machine, and then after that the component will be placed over that. After that, due to temperature variations, the component will get attached to the paste and the board. Then comes quality check, which is nothing but AOI, automated optical inspection. This one is nothing but the program. It will, you have a specific program where we will capture the previous data, and we will compare with the current board which is produced. If there is any variation, the board will be rejected. Then the product will get off. So this is the whole area this industry is contributing. And we have several horizontals in this industry, like schematic capture is a you have a separate role where you will develop the circuit. PCB design is a separate role where you will design components and design the board. And analysis is the separate role where you will analyze the circuit board designs, whether it is electromagnetic compatible, or whether the current or my signal is getting propagated in a desired manner, or how much of noise the board board is holding. So that sort of things. So this analysis is carried out using ANSYS, and this schematic capture or this PCB design are done using some EDA tools. So, and then if you are interested in manufacturing, then there is also a lot of opportunities available in the PC manufacturing area, where they will be responsible for programming the automated line, and they will also ensure the product is getting produced with zero quality issues. So then we have, in this area we will be using CAM kind of softwares, and this area is CAD kind of software, CAD tools. This area is fully CAM kind of softwares. So how the data is transferred from design to manufacturing is, we will say it as Gerber data. Gerber is nothing but a format of transferring data, which is nothing but machine to machine communication. And then, so these are the basic functionality of this industry. So the challenges which we are facing at present is, there is no specialized course in the college or universities or in the outer atmosphere. So it is quite difficult for a graduate to get on to this industry as a fresher. So many colleges, abroad colleges in the Europe and in America, they are trying to include the printed circuits as a part of the curriculum. So hope, if you can if you can learn about this, you have a bright future here. If you are interested in hardware, because hardware is the basic thing. Software is just implementing on the hardware. So if you are interested in this thing, you can learn from the all the sources available in the outer space. Only very few online courses are available, that too on software tools. It is a, they will not teach the PCB related concepts. So the only thing which help us is that all the engineering studies which we do do in our college, just all the concepts, all the electrical concepts I am applying in my day-to-day in industrial life. So if you are strong in your fundamentals, then learning a software is not a matter of time. So this two are the major challenges faced by this industry. So there is no specific curriculum, so it is quite tough to learn from outer atmosphere also. So I will give you some insights on how, where some contents are available in the later on. Why this industry has a huge potential? What is the necessity of this industry? So as you are well aware, electric vehicle is going to be the next stage of our transportation for reducing the pollution level, and IoTs are picking up, then AI, big data. So all in all, this all needs the hardware device. So this hardware device has to be manufactured. So there comes the printed circuit board, because if you're going to develop a IoT product, take it a Raspberry Pi, it is a printed board. So all these things, printed boards market is growing day by day. So there there comes the major need of talented peoples for design and manufacturing role. So and then another opportunity is thus, all the peoples in this industry are in the retirement stage. So we are hoping there will be a huge openings in this industry. You need to tap at the correct time. And then with the evolution of printed circuit boards, next stage of development is printed electronics. So printed electronics is going to create a enormous amount of amount it going to create enormous it is going to needs enormous amount of talented people. So if you are strong in PCBs, then printed electronics is just going to be easy for designing. And these are the some of the tools which you can use for free. So you can download from the Google and you can practice with this tool. And there are many more tools available. These two are quite easy to handle. And the tools which is used in the industry are this. Altium is the most common and popular one, and Cadence Allegro, it is the low cost tool. Major all companies prefer this one, and Menta Graphics is the standard one. Then Autodesk. All these guys are EDA developers. So learn about have an insight about electronic design automation. So you will get what is the EDA is about. It is all about digital electronics. And some useful websites are SemiWiki. SemiWiki is a kind of information where you will get all the information related to semiconductors. Here, all the employees from top organizations will be blogging. So this one is the major platform which all will be using for uh, for knowing what is going in the at present industry. So this one, so this semiwiki.com is a major useful resource you can use at the college level, and it is free, guys. It's all free. So you can use, and you can be up to date what is going in the semiconductor space, and how the semiconductor industry is going, what is the next tech it is growing. So everything will be updated day by day. So you can use this, and it is a really useful resource. And then comes iConnect. This iConnect is specialized resource for PCBs and SMT related things, and this is also entirely free. So with this, with the help of two, I hope you can get up to date stuffs in the semiconductor and PCB space. And if you want to learn about PCBs, these are some reference books, and this one is a complete reference guide. This one is the complete reference guide, and this one is really good one. As a fresher to start, this one is good one, but only thing drawback is the cost of this book. So if it possible, try to get some free versions in Google. So this one will give a complete overview of what are the printed circuits, how it evolved, what is the manufacturing process used, and how a designer needs to think, how he need to handle the various design complexity. This is the wonderful book. And right the first time, actually, this book, in printed circuit boards, we will classify designing into two stages: low speed design and high speed design, based on the frequency of operation. So in a circuit, what is the circuit's operating frequency? We'll check. If it's below 350 gigahertz, if it is below 350 gigahertz, we will classify it as a low speed, and if it is above, we will classify it as a high speed. So this right the first time. This all deals with high speed kind of technique. Low speed is the starting one. If you have been quite flexible with low speed, you can then go for high speed designs, which involves 10 layer board designs and complex board designs. Then comes signal integrity and printed circuit boards. This signal integrity and printed circuit boards. The signal integrity issue. What is this is about? The what I told about the propagation and the reflection coefficients, so and so stuffs. The signal integrity. And if you are more eager to learn about analysis, you can use you can use Actually, this is a professor. He's a professor, well-known professor. He's a signal integrity expert, and if you have interest in getting into analysis stage, you can use his resource, which is quite interesting. So he's a professor, and at the same time he is also holding a signal integrity journal. So you can use this is complete signal integrity academy, where he will keep books posted, or he will do webinars, lot of stuff. And this one really helps you to understand about real need of S parameters, why frequency domain is so important, why we are shifting from time domain to frequency domain. And then there comes, these are the technical associations. From here also you can learn a lot of things about printed electronics and printed circuitry. And this IPC is all about the standardization organization, which will release standards for designing. So I have told you we will decide the pattern width based on the amount of current. So all this calculation will be governed by this IPC standard. And then comes SMTA, Surface Mount Technology Association, which is responsible for surface mount technology manufacturing process. So this with this the help of this, you can get an insight of all the surface mount related manufacturing techs and all this that sort of things. And then comes INARTE. This association is for electromagnetics. You can just gain knowledge for analysis purpose. You can use this association, where you'll gain knowledge related to electromagnetics and that sort of things. So guys, this industry is going to grow. So if you are really interested in printed electronics and how this printed boards are manufactured, how it is designed, you can get into it. You have a bright career ahead. But only thing what you need to ensure is that you should have a you should have a high tight grasp on all the basics in your engineering. That is the only thing expected. With that, all the basics stuffs, of all the basic stuffs, you are strong, then you can get into this industry. And with this reference, I hope you can get, if you are interested, if you are trying to learn, you can use this resource. This are some almost free resource you can use. And that marks the end, and these are the challenges and opportunities which we face, and these are the design process we are using now. So any queries?
Any queries from student side? Students, if you are having any queries, unmute and ask your questions.
Students, kindly ask your questions.
Any questions? Any doubts? Any questions? Okay, ma. Thank you, Dinesh. You have given a brief introduction about the PCB. I will hand over this session to Nagabalan sir. Nagabalan sir? Nagabalan sir, please sir.
Yes, sir. Yes, ma'am.
Please sir.
Thank you, Dinesh.
Thank you.
Good evening, everyone. I'm honored to and lucky to have the opportunity to give a vote of thanks on this special day. I particularly like Mr. Dinesh where he mentioned the opportunities in PCB industry in this webinar clearly, and the way in which he explained the subject was extraordinary. I would like to thank our management, principal sir, HOD ma'am, dear coordinator ma'am, all the counselors, and also the faculty members. I must not forget to thank all our participants here who involved actively and participated well in this program. I would like to thank again for making this event a success. Thank you all.
Dinesh?
Yes, ma'am.
Dinesh, this is Sumitra, ma'am. How
Yeah,
are you,
ma'am.
Dinesh?
Fine, ma'am. I saw you in the call. I was doubted
Okay.
whether this is Sumitra, ma'am, or...
I'm happy to have you as a guest today. Your presentation is excellent.
Thank you, ma'am.
Okay. Keep in touch with us. In future also, we'll be hoping the same thing for other departments, even for other years also, right?
Sure, ma'am. It's my pleasure.
Okay, ma. Thank you, ma. Thank you.
Thank you.
Dear students, kindly fill the feedback form which is shared in the chat box. Kindly fill the feedback form. So it is in chat box. Kindly fill the feedback form.
Thank you, Dinesh.
Thank you, ma'am.
தேங்க்ஸ்மா, ரொம்ப நல்லா இருந்தது. உங்களோட ப்ரெசன்டேஷன் ரொம்ப நல்லா இருந்தது.
Thank you.